as a quick overview on this lesson, forces and equilibrium. I explained in the class the introduction of the forces. We define the force, we specify the effect of a force, and the two categories of the forces. We can classify the forces into contact forces and forces acting from distance. We know that the contact forces are muscular elastic, which is the tension force, reaction of support, and it's also called the normal force and the frictional forces. And while the forces acting from distance, in which the two objects are without physical contact, they are magnetic force, gravitational force, we mainly say weight, and the electrostatic force or the electric force. So the characteristics of the force are the point of application, it's where the force originates or starts, the one of action, direction, and magnitude. The first force acting from a distance we're going to talk about is the weight, which is the gravitational force. We know that weight equals mass times gravity, and the SI units of these three parameters are the weight in newtons. Of course, any force has unit in newtons. The G, which is the gravity, and M, which is the mass in kilograms. Note that the gravity is always given about 9.8 or 10 newtons per kilogram. This is the unit conversion for the mass. The weight and the gravity are always given in SI units, so there's no need to give the unit conversion. And this is a simple example on this formula: weight equal mass times gravity. We can try this. Okay, we always draw the weight from the center of mass of the object and downwards. Okay, the magnetic force between the magnets. We know that same poles repel while opposite poles attract, like N and S. When they face each other, they attract. The two magnets attract, and the magnetic force is always drawn from the center of mass of each magnet, and whether it's attraction or repulsion. The electric or electrostatic force is the force between the charged objects, يعني positive or negative. Same poles repel, opposite poles attract, same as magnetic force. But this is because due to the charges, while this due to the magnetic field of the magnet. Now the contact force is the muscular, the normally action of support. Normal is always drawn perpendicular to the surface and not upwards or downwards. The frictional force is always drawn opposite the direction of motion. You can, of course, read and understand well the note given. The tension, which is the elastic force. Now, I'll talk into details in a minute about this tension force. Okay. Tension force, we can calculate the magnitude of the tension force using this formula. Tension is equals to K times delta L, where K is the stiffness of the spring, and delta L is the elongation. It means how, or compression. It means how long the spring is elongated, or its length is increased or decreased. Um, of course, tension has unit in newtons. The stiffness is how much the spring is stiff. يعني قديش سميك أو قديش بيحمل قديش بيتحمل. And delta L is the elongation. Okay, this is the Hooke's law. I'll stop here and I'll open an application showing the application of Hooke's law on a spring.